The greatest engineering success of the 21st century has also become our greatest environmental disaster. Since the 1950s, we have produced over 10 billion tons of plastic worldwide. This durable, cheap, and lightweight synthetic material has seeped into every area of modern life, from packaging to consumer goods. But this very durability, which once seemed like a benefit, is now a catastrophe for our planet. The problem is not only the sheer scale of production, but also the complexity of our waste management system. Only a very small percentage of plastics can be effectively recycled. The rest either waits for centuries in massive landfills or, worst of all, seeps into the oceans, embedding itself in the tissues of every marine creature. Microplastic pollution is now detected everywhere, from polar ice caps to human blood, illustrating how deeply we are drowning in our own invention. But science has gone to the root of the problem. If the issue is that plastic is made from petroleum and rejected by nature, then the solution must be to change the source. We have turned our gaze toward the soil, toward corn, sugar, and algae. The age of bioplastics has begun, offering a new path forward. Bioplastics are revolutionary polymers whose origins lie in renewable biomass. We essentially examine two main categories, each with distinct properties and applications. First, bio-based plastics. Though derived from biomass, their chemical structure is similar to conventional plastic, and they do not readily decompose in nature. Their importance lies in reducing petroleum use and leaving a lower carbon footprint in production, making them a more sustainable choice. One of the most common bioplastics, PLA, or polylactic acid, is obtained by fermenting the sugar in vegetable starch and then polymerizing that acid. Polymer chemistry expert Dr. Elias Thorne summarizes this shift. Unlike petroleum-based plastic, PLA's carbon cycle is relatively closed. The plant takes in CO2 from the atmosphere. We convert it into a product, and when properly degraded, the carbon returns to the cycle. It's more than just a product, it's a covenant. The second, and truly revolutionary type, is biodegradable and compostable plastics. These are specifically designed to break down rapidly under specific environmental conditions. One of the most exciting developments is the PHA class. Certain bacteria naturally produce these polymers within their cells to store energy. These bacterial plastics are one of the purest solutions nature offers to our crisis, being both bio-based and capable of degrading rapidly, even in seawater. However, the success of bioplastics is heavily dependent on proper waste management. This is where the great misconception comes in. Consumers often assume the biodegradable label on a product means it will break down if they throw it in their backyard. Yet, most bioplastics, particularly PLA, require industrial composting conditions to break down. Temperatures above 60 degrees Celsius, specific moisture levels, and a balance of specialized microorganisms.
These conditions cannot be met at home. If you throw this bioplastic into the standard recycling bin, it contaminates the conventional plastic and renders the entire batch unrecyclable. As waste management specialist Maria Sanchez points out,
industrial composting is our chance to view bioplastic not as waste, but as a resource. But without adequate infrastructure, this material risks becoming a burden on our existing recycling system rather than a solution.
Therefore, the key to future waste management lies with cities that can establish the composting infrastructure needed to handle this separation. For the bioplastics industry to truly grow, investment must be made not just in production, but also in the final stage of waste management. The journey of bioplastics is not perfect. We face an ethical dilemma. The agricultural land used for bioplastic production is a resource that could potentially be used for food production. This fuels the food versus plastic debate, a critical consideration for sustainable development. Environmental ethics professor Dr. Lena Weber addresses this challenge.
We don't want to solve one problem to save the planet only to create another. Therefore, the focus must shift from food crops like corn to secondary biomass sources such as algae, seaweed, or agricultural waste. True sustainability lies in turning waste into a resource,
maximizing efficiency and minimizing environmental impact. Nevertheless, bioplastics offer us a seemingly impossible promise. The promise to meet our needs while safeguarding our planet's health. They are the most tangible product of the alliance between science and nature, a testament to human ingenuity. The struggle continues in cost, infrastructure, and consumer education, but the potential is immense. The plastic crisis was a consequence of humanity. Finding the solution and disseminating it throughout the entire system is the task of a generation of scientists and decision makers. And ultimately, it will be made possible by the conscious choice of each one of us through our daily decisions and support for sustainable practices. We are building a future that allows not just recycling, but a return to nature. And this is the greatest progress our planet deserves. We've reached the end of another video, friends. If you like this video, don't forget to like it. We'll learn a lot from the videos I share. Don't forget to subscribe to my channel so you don't miss my new videos. See you in the next video.